Hey y'all, in this video I'm going to go over our robot framework, DoesRobot. Right now, DoesRobot is a collection of scripts that helps us make robots. We use VS Code, FreeCAD, GitHub, the terminal on our local machines, and other tools to make robots. But the goal of DoesRobot is to give us a strategy that ties all these different tools together. I'll show you how to install DoesRobot on your computer, and I'll show you some of my favorite features. Let's start. I'm working on Windows, and to get a bash terminal on Windows, I use the Windows Subsystem for Linux Ubuntu app. First, I'll start off by cloning DoesRobot. Grab the link here, git clone. Great. Now if I list it, I'll see I have DoesRobot. I'll cd into DoesRobot, and I'll run bin setup. Great, now I have access to the bash scripts. I like to put my robots in my robot directory. Here are some of my robots. Let's make a new robot. We can do that with our DoesRobot command. After typing DoesRobot, we'll pass the name of the robot. Right now, we'll just call it TestRobot. TestRobot is alive. So you can see here that TestRobot is right here. We'll head over to TestRobot. And right now, it just makes a parts directory. So we'll go to that parts directory and we'll open up FreeCAD. FreeCAD is a CAD program for manipulating and creating 3D image files. It's our preference and it's what we'll be using for the framework. To open FreeCAD, I can type doescad, and I don't have any FreeCAD files right now, so I'll just do dot to open it. Now that I have FreeCAD open, I'll start making my robot. To do that, just do File, New, and let's go to the part workbench. This won't be a sophisticated robot. I'll just add a cube and a cylinder. Let's move this over here. FreeCAD's awesome. You can do all sorts of things to manipulate objects. Like I can cut that cylinder out of this cube right here. And because this is just an example, that's all I'll do for now. Now that I've made something, let's save it. File, save as. I'll go to my robots directory. I'll find my TestRobot folder, go to parts. Let's just call it TestRobot, and I'll save it. One of the helpful scripts that we've made for DoesRobot is to export our entire robot as an STL file. Exporting as an STL file is really useful because STL files are industry standard and are really easy to see and view on GitHub. To make a macro in FreeCAD, click the macro menu bar, go to macros, and click create. This macro will create a STL file for our entire robot, so I'll just call it full STL. It'll open the file editor for the macro, and I will copy and paste the code here. Head on over to GitHub and go to FreeCAD scripts. Here you'll see the full assembly PY. Select all of this and copy it. Head back over to FreeCAD, paste it, and file save. For ease of access, let's add this macro to the menu bar. You can right-click the menu bar, click Customize, go to Macros, and you'll see your list of macros here. Ours is the full STL. You have to give it a name, full STL. You can choose an icon for it. I'll just choose this one. And you can add it. So now you can see it's added here. Go to Toolbars. I like the part design, so this will work fine. head over to macros. You need to make a new toolbar category for your part workbench. I'll just call it my macros. And now move full STL to my macros. You can see it popped up right here. Close this, and all I have to do is click full STL and it'll execute the script. If I head back over to my terminal and look at all the files and parts, I'll see that we have our FreeCAD file, DoesRobot, and our full assembly STL file, which we created with our custom macro. Now that I've created my robot and have an STL file version of it, I'd like to push this up to GitHub so that everyone in the world can see it and people can collaborate and give me their ideas of what they think about it. I'll head back to the root directory of this robot, DoesRobot, and I'll make a GitHub repo for it. So I'll git init, I'll git add everything in DoesRobot, and I'll commit this. Now I'll head over to GitHub and make a repo. I'll make a new repository. Let's call it DoesRobot test. Create. I'll copy the link and I'll follow these instructions because I've already initiated a Git repository locally. So I'll add the remote, git branch main, and I'll push up to GitHub. Now on GitHub, we'll see the directory and all of its folders and files. Right now it's still very simple. So we've got our full assembly and our FreeCAD file. The full assembly file is visible on GitHub, which is really cool. It makes it easy to send people links to what your robot looks like. Now let's make a change to our robot. We'll head back over to FreeCAD. Let's say instead of a cylinder, we want to cut out something else. To do that, you have to delete this cut object to get it back to the cylinder and cube, and then we'll delete the cylinder. Let's just import another cube, and let's change the dimensions of this cube. Let's make this 5, and this 5. And now let's delete that new cube from our old cube. Now we'll run our macro so that our STL file is updated, and we'll save the FreeCAD file. If we head back over to the terminal, let's push these changes up to GitHub. We'll git add all, git commit message, change cube, and we'll git push. Now let's head back over to GitHub. Here's our original cube file. We can click history and we can see that there are multiple events for this file. We can open each of them. Let's look at our changes side by side. For more complex robots, this will be really useful to be able to communicate differences and see the progress of its updates over time. Comment below with any features you would like to have to make the robot creating experience easier. We're a new channel, so like and subscribe to get more updates about our robot projects and to get more updates about our framework DoesRobot. Have a great day.